There we go. Okay, well, welcome everybody. I'm Jessica from the Research Foundation, and we are pleased to have Craig Rigby and Jim Symanski here. We wanted to really get you some insights. Let me admit a few more people. We wanted to get you some insights into the battery industry. We have a lot of projects going on at UWM, and I know there's some folks who are from outside of UWM also attending today. We just want to give you an insight into the real industry and really what you need to do to get your technology to the next level. Battery industry is really hard, and from our learnings at the Research Foundation even, we're finding it almost like a pharmaceutical technology. It can take a decade or more just to break in and get it to a high enough level. And there's only so many large companies, doing and making the batteries at a high level. So I don't want to take too much time here. I want to pass it on to Craig and Jim and have them do an introduction to their story, their bio, and then we can go on from there regarding the market and the industry and their insights. So Craig, maybe you can kick it off. And also thank you to Craig. He is one of our board members at the Research Foundation. If you all might just mute yourself, just we'll make sure we have no feedback. Thanks.
Thanks, Jessica. And first of all, thanks for organizing this. I'm happy to be here. It's hopefully have a good conversation and share some thoughts and ideas. Yeah, my name is Craig Rigby. I lead advanced technology development and our technology scouting efforts here at Clarios. You may not know who Clarios is, but you probably know who Johnson Controls is. And so Clarios is what used to be the battery division of Johnson Controls. And that transition happened through a sale process back in May 1 of 2019. So we've been coming up on 2 years as Clarios with a new and broader perspective on the battery industry, and excited to share some of those thoughts with you. Quick background on me. Jim, when he gets to it, I know will have a much more traditional and relatable path in terms of batteries. Mine is not normal. By training, I'm a naval architect, marine engineer, graduated from the University of Michigan with a degree in that. And spent the first 7 years or so of my career doing ship design, ship construction, before migrating into the automotive business. I spent 7 years at Ford Motor Company doing a lot of powertrain advanced technology stuff at Ford, and was part of the development and launch of the first generation of hybrid electric vehicles at Ford, which is really where I got more into the battery. And when that process was launching, I was actually got dedicated to the high voltage battery system and the technology that was being used there, and really got myself immersed in the technology, the way it was being used, the way it could be optimized, what the trade-offs were. And that led me to a transition to coming to Johnson Controls, initially being involved in the lithium ion part of the business, which was a joint venture at the time with another company. That's where I met Jim, and really started my, in earnest, I'd say, my education about batteries, battery technologies, and really trying to understand best I could, not just what was happening down in the chemistries itself, but really taking that up to how they can be used, what the value can be created, whether it's in an automotive application or otherwise. And ultimately, I'm trying to understand how different technologies can be applied in different ways to create value, to make things work better, make them more efficient, and ultimately create a market for the products that we're trying to develop and sell. Over the last, I've been here now at 14 years with what's now Clarios. And in that time, I went around in a few different places. I ended up running the global engineering group that covered both lithium ion and the lead acid technology that is the primary product that we have today. And also led the product management organization, which is essentially really trying to synthesize what we see happening in the industry. What are the drivers that are going to shape the needs of our customers in the long term, and trying to anticipate that, both in terms of what products we need to do, but what technologies we need to have in our portfolio in order to, to support those products in the next generations. For the last 5 years, I've really spent the bulk of my time focused on technology scouting, getting out even further on the horizon of what's emerging from a technology perspective, and crafting partnerships, in some cases licensing agreements, in some cases acquisitions of technologies that we feel are important to our future and that we want to have available to us to develop into products. So hopefully with that, while it's not necessarily a pure path to through the chemistry path, I can bring something to this conversation in terms of the way we think about technology and the way we look at market opportunities for those technologies. Jim?
Great, thank you. Jim, do you want to take over? And just when you guys have any questions, feel free to also use the chat, but we'll have plenty of time for questions as well. Go ahead, Jim.
Jim, you're on mute.
Okay, there we go. Now I'm on voice. Just a couple quick questions. How is this agenda going to run? Are we going to introduce ourselves and then have a discussion?
Yeah, Jim, I think just get a little of your background, and then each of you can speak about your perspectives, on the industry, breaking in, whatever you want to speak about. Your tips.
Okay, yeah, because I did put a couple of slides together that I think
that is fine as well. Yep.
Yeah, and the question is the timing on when to present those or talk to them. But anyway, go ahead.
It's all yours.
All right. So I'm Jim Symanski. I'm a retired.
Maybe jump into the slides right away.
Jump into the slides right away. All right. I'm Jim.
No. After your.
Okay. I'm Jim Symanski. I'm a retired director of engineering from Johnson Controls. Spent 32 years there, and my career follows a timeline that I think will be helpful to those on the line. I started out as a PhD graduate in the R&D group of JCI, and progressed through various levels of technical expertise and management, going through the phases of R&D, product development, product qualification, technology scouting, and technology evaluation. I retired 3 years ago, and presently, right now, I'm just doing a little bit of consulting on the side, helping out with the UWM program, and I'm happy to engage the group here and answer their questions and kind of give them an insight in terms of what the battery industry is like. Okay, Jessica.
Feel free to jump into your slides and show us whatever you feel.
Oh, okay, great. Let me see. How do I do that? I can share my screen, correct?
Yep, at the bottom or on, you'll see share screen.
And then once I do that, I say share. And are you seeing my screen right now?
Yes.
Okay. There we go. All right. Basically, I've kind of come full circle in my career. Full circle meaning that I like to simplify things and create one-page little models of my responsibilities and the kinds of things that I've learned. And basically what I'm going to tell you about is my career has kind of followed this in terms of what I'll call our high-level pillars of technology. And those high-level pillars are in the development of the technology, the assessment of the technology, of scouting other technologies and trying to benchmark them. And then eventually, once you have the technology in hand, or you think you've got a handle on it, how do you market a commodity that you have that you think is valuable in the battery industry? And I think these pillars are focused for me on 4 key functions or attributes of the technology, namely performance, life, cost, and safety. And what I want to highlight here is just no structured thinking, but basically general thinking in terms of when you look at a technology, what do I look for? In terms of the performance side, obviously it's the failures. How are they going to fail? Are they, what are the material properties used? What are the design functions that someone is trying to convey to me? And immediately look at the trade-offs. And in a typical battery application, the power energy trade-off is a very common trade-off, and we need I'd like to understand what those are, and basically what the failure mode is, and how well someone's taken their technology in terms of failure analysis. Then we look at the cost. When someone is showing me something, basically what are the processes that they're using to get there? Where do I involve it in the processes that I own in terms of producing batteries? What's the supply chain? What are the limitations? What are the process aids that people use? One of the life lessons that I learned in the early days of lithium ion was that basically in terms of, what I'll call a process aid, which is really a supply, is arsenic salts were very popular back in the 80s, and that wasn't going to make it in a commercial battery venture. Hence, today we use LiPF6. What are the quality requirements on materials, raw materials? And then, eventually, how do you, at the end of life, how do you dispose, or how do you recycle your materials? Because it's going to come back in the long run and add cost to your technology. And likewise, going down to the last item there on supplier quality, what kind of requirements are you going to, require, or are you going to have on the people that are supplying you things? All right. Life. I'll just touch on a few of them there to get us moving along quickly. Basically, what are the life expectations? How does it form in extreme environments? Can you show me accelerated tests that will help ferret out your life? And then finally, in the life arena, as we would deliver batteries to customers, it's the end of life function requirements that we have to meet. And obviously, we have to add material margins into our batteries so that as they degrade, they fulfill their functions at the end of the expected life. And then the last thing and very important thing is safety. Failure per your failure modes effect analysis, your in specification use. Yes, you're great, you do this, but what about people that misuse the system out of specification or go to the extent of abusing? And that's where you need to understand what you're proposing. And then finally, there are specified test matrix. So this is a living graph that I carry around with me, and every once in a while I'll throw something on there or go down a path. But I think it's a good thing to keep in mind overall for your people that are developing battery technologies, is they need to understand very quickly how they fit into the big picture. And I know we have, in my experience, I had a lot of people come in and say, I have this great material. It's for lithium ion batteries. You should be very excited because lithium ion batteries are big. And the answer is, yeah, you're not telling me anything new, but you got to tell me more about what you're doing or what your path to the future is with this material. And I think, in terms of innovators, researchers, and developers, if you've got a grasp on that, then you've got a better channel of communication to those in the battery industry, not just as necessarily coming up and saying, hey, lithium ion batteries are big. I know that, but you got to do more in terms of the path to success and walk them through it. And then say, going on to, I got a second slide here. And this is something that I picked up from a friend of mine. His name is Ralph Broad. he wrote a report for the government in 2006. Basically, the report was, focused on why are there no volume lithium-ion battery manufacturers in the United States. And this is more of a structured development plan in terms of advancing technologies. And, Jessica, as you said, it's kind of like, we can make an analogy to the pharmaceutical industry if you want, in terms of times of development. You begin with a concept and you validate it and you do your R&D. You take it through your phases of applied research into development and then into advanced development. And even when you're in advanced development, you're only at, 3 to 5 sizable pilot trials to run it and be able to get good engineering samples to do what you would call as your full commercialization type tests to understand repeatability and deviations. And then the little chart at the bottom kind of just shows you the scale in terms of where the development stages are and what the resources that required are. So, basically, if you have a material and you're doing a concept validation and research, your relative cost index there compared to, what it's going to cost to get that technology into development is 25 times less than, even to get to the advanced development side. So this is where I think it's important for those that are developing technologies. They don't necessarily have to have all the answers along these paths, but they should be aware of them, that they will be asked them, because presently in the United States, corporate R&D and applied research is pretty much at a minimal stage. Even when I was retiring from JCI, most of us were just doing development engineering to get cost out of product or to get productivity up. We weren't looking at anything that was, game changing or bringing in, new or better technologies. So with that said, I'd like to conclude and turn the screen back over to you, and we can move on. All right, Jessica. Yeah,
that was
you're welcome.
great. That was really great summary, and I think it'll go well to move on over to Craig and what he has to talk about.
Yeah, so I would agree that what Jim described, especially on the first slide, I think is really a critical thing to grasp, is that to be commercially viable, it's not enough for a new material or a new cell technology or design to be really, really good at one thing, right? If you are not answering all the questions that are implicit on what Jim talked about around not just performance, but performance and cost and life and safety, and really understanding that as a total system and a total set of requirements, it's going to be really difficult, because the way if I break it down in very practical terms, if you're bringing a new technology, unless by that technology you're creating a whole new market with a whole new application that's never existed before, then what you're trying to do is you're trying to displace something that's already there. So if you're going to try to displace something that's already doing the job and you think that technology can do the job better, that's completely a good target and objective. But it's difficult to displace something that's already there, especially if that technology is in production in a mass production way with cost curves that have gone down. You have to find ways to make such a compelling story for what your new technology or your new innovation can do, that you have to really make it compelling. Now, it won't just be enough to say, well, it performs better, because even if you could use something, meaning it will perform better than what's there today, you're going to have to ask yourself the question of, would I do that? And that brings the question of cost in. Just because it can do something, if it can't do it at a cost that makes sense or creates a good value proposition for a consumer or for a customer, it's not going to win. It's like Betamax, right? Betamax versus VHS. It was a better technology, but it wasn't widely distributed. It wasn't at a low enough cost. It didn't win. The same is true in battery industry. So you have to get past that point of, does it make sense economically? Does it make sense from a manufacturing perspective? Many of the things that Jim touched on play into that question. And then I think the third thing that he also touched on, but I want to highlight a bit more, is the notion of life cycle. And what's becoming more and more apparent in the industry today is the need for end-of-life solutions, whether it's recycling, recovery, reuse of these technologies. The idea that a battery technology can be produced and then just put into landfills at the end of life is no longer going to be acceptable. So, if you can make something that performs better and you can do it at a cost that makes sense and creates a good value proposition, you still have to raise the question, should I do it? Am I using chemicals or materials that are dangerous or have, are difficult to manage, or are going to have a toxic impact on the environment? Do I have end-of-life solutions that are going to create a closed-loop economy for those materials so they can be reused and make something that's more sustainable? So I think if you really, I see a lot of stuff that on paper sounds great, and even to the extent you see proof of concepts that are really high performing, but the rest of that whole question of cost and feasibility and life cycle solutions, it's, unless you can present that whole package in some way, at least the perspective of it, or the prospect of it, it's really difficult for a company to latch on and say, yeah, that's the technology I want to work on, without having at least some understanding of how those other things are going to go. So I think what Jim talked about with the 4 quadrants really does set up the broad view you need to have, even if you're working on a very specific technology.
Yeah, and Craig, I kind of like the 4 quadrant approach because, and with all the scattered bits and pieces in each of them, is because you don't need to bring a full solution all the time. What you need to understand is what you know, and what you don't know.
Right.
And you can always look at someone else's technology and say, you know what, they've got 3 or 4 things in there that are good, but one of their shortcomings I can handle. So you don't necessarily need to develop something new, but you need to provide value to the overall system. And
right.
That value to the overall system could be an improvement in a shortcoming. And then likewise, it's also an opportunity to set expectations with the people you're working with. When they come forward to you as an R&D director or an engineering director, I've got an idea. You pull it out and say, okay, what problem have you solved? And have you looked at the other ones? And, if something there is unsolvable, we agree to put it on the shelf. And we also agree that we would pull it off the shelf if certain trigger points are met.
Right. Right. The other thing I'd say, and maybe this is goes against the current trend, is when we think about batteries, we tend to think, we can tend to think in a very narrow perspective of what's good, right? And there's a ton of attention on lithium ion, and rightly so, because it's important in enabling certain things. But for all the attention on lithium ion, it is very good at certain things, and the weight to energy and weight to power ratios are quite good relative to other chemistries. But it is not a silver bullet. It is not the singular solution that can solve every problem. And I think one of the other things I would just want to convey is that when ideas are coming up around new materials or new combinations of things that can achieve different performance objectives, they shouldn't be dismissed if they're not competing with lithium ion. If they can't overachieve lithium ion, that doesn't mean they're not useful. I've seen technologies, I'm looking at technologies literally now where they've directly said, we're not trying to compete with lithium ion, we're going to go in this other direction. We don't get technologies that are as light as lithium ion, but they do these other things better or at a lower cost or with better sustainability. There are markets for those solutions. They don't have to be that one thing that powers an EV. An EV is not the only technology that needs a good battery.
Craig, speaking of that, we just had a question from PG that how important is sustainability and the environment in the industry right now when compared with cost and quarterly profits?
Very interesting question,
You know,
and a good one. I was muted, so I was started to answer. I'm sorry, Craig.
well, go for it, Jim.
Yeah, I think it's becoming more important. It still isn't overwhelming from when I left the industry, but I kind of look at what GM and Ford are putting into their television advertising, and I think what they're trying to do is it's on the radar screen, and in the future it will be as important as cost and quarterly profits. But Craig, you go ahead.
Yeah, I think that's true, and I agree with Jim. It's becoming more important, and it's becoming a top of the house priority at the major companies, whether it's the automotive companies or other companies. So two things we're seeing with that is the investments, not just in the development of the technology, but the understanding of end-of-life solutions is becoming more and more important, and it's driving decisions. It's also driving investment. What we're seeing is investment, not just in materials companies to create new battery technologies, but in companies focused on recycling and other ways of reusing materials. They're getting a lot of investment as well. And to me, that's an indicator of the relative importance. And I think the last thing on that is you are seeing some organizations that, NGO type organizations that have a presence here, creating sort of the notion of what sustainability should look like with batteries. And I think what you'll see in the next few years is those sorts of things take hold and become de facto definition of requirements, if not enforceable, at least a guideline as to what the expectations should be. So to me, we're moving in the right direction with that.
We got several new questions here. If you want me to read them out, we've got one from William. Can you estimate what the possible relative improvements are in the current energy and power density capabilities in car batteries 10 years from now?
So I would say one specific point I can touch on, and then Jim maybe can dive a little deeper, is, I think by car batteries, I'm going to assume the references to batteries that are traction batteries for EVs, right? So lithium ion, state of the art, like a Tesla battery. The question of what comes after lithium ion typically has been a better lithium ion, and I think the thing that would characterize a better lithium ion, that it probably fits in the time frame that William's asking about, is solid state. That's a sort of a nebulous term that has a lot of sub branches in terms of materials they're using. But the notion of going to solid state, which improves safety, can improve energy density, enables the potential use of lithium metal anodes, which drives a density question. The prediction is you can get about 2x improvement on energy density with that technology. Still to be proven. I've seen samples that are in the 1.5x times current state. So there's still ways to go, but the expectation is that technology will be commercialized in EVs probably in the 7 to 10 year timeframe.
Next question from William is there a better technology for energy storage systems to support the growth in renewables?
So I'm not going to try to name something, but what I can tell you, at least with that application, and this I think it's a great question because it gets to the point of what is it that matters in any given application? And Jim, laid out all these different parameters, and most often they're trade-offs against each other, whether it's power or energy or cycle life or calendar life. In this case, with grid storage on renewables, the renewable cycle is such a long charge discharge cycle over like a full day. So you have a 12-hour cycle where you might be charging those batteries, and you have a 12-hour cycle where you're discharging those batteries. Say you're talking about solar and you have discharge over the nighttime. Whereas in a lot of applications in the automotive industry, cycle life is absolutely critical, and you'll pay a premium for a technology that will cycle really, really well, especially in hybrid applications. In that case, the cycle is so long and you're doing relatively few of those cycles in the lifetime of the battery. What ends up happening is that the actual upfront capital cost of that technology becomes more important than how well it cycles. And so what that means is you need to drive to technologies that have an inherently lower cost. Really, that comes down to the materials cost. And it can start to exclude some of the technologies we think of today as being the leader in the space. So, I'm not going to try to answer exactly because I think the answer isn't known yet, but the parameters of the application sort of define the window in which you have to operate, or otherwise it's not going to be commercially relevant.
We have another question from Patrick. I know a lot of new technologies are hard to do accelerated testing in contrast to lithium ion batteries, which is fairly easy. How do you convince investors of lifetime when you can't demonstrate lifetime on a lab scale?
I'll jump in on that one. I think that's interesting because he said lithium ion is easy. Way back in the 90s, it wasn't easy. And, through the process of discovery, and we'll walk through that process, I think we've learned how to do the accelerated testing in terms of we identified what the failure modes were. And then you go after those specific failure modes. And with the lithium ion technologies, with the very early technologies, it was the calendar life. And it was basically at elevated temperature, calendar life would go down. So I think, to answer that question in brief, you need to just kind of sit back and think, well, what is the failure of your, let's see, I know a lot about technology, harder to get accelerated testing. How do you convince investors? What you go back to, I would say, is basic principles. In other words, if you do understand the technology, you understand what its main reactions are, and you gain an understanding into what its side reactions are, you can probably, with a lot of thought and a little bit of experimentation, understand how you can accelerate those, quote, side reactions, the things that aren't supposed to happen in the battery, and understand what the impact of those side reactions are on your overall battery function and performance. Hopefully that will take care of your question, William.
Okay, and Diang was asking, what do you think the impact on traditional vehicle industry is if Apple starts to produce EV?
So yeah, I'll take that one. And then I see somebody said when, so I think that's a fair tweak on the question, because Apple's been they've had different levels of commitment about this. I think it's going to be interesting. Apple is really, really good at developing a product in the absence of people realizing they needed the product, right? And I think the iPhone and the iPad demonstrate that really well. I think it's a different challenge when it comes to automobiles. Now, the caveat here is if they come out with some sort of approach to, I'll use the term mobility rather than the traditional car, the way we think about it, then I think that's actually pretty compelling and that could be a game changer. But I think it's more likely that they come out with their version of what a car looks like. And And I think the lesson that will be interesting to see is it's hard to make a car, right? I use the example of Tesla versus pretty much everybody else. Tesla is really the only new car company that's demonstrated staying power and really any measure of success in really probably my lifetime. And we've seen a lot of people try to start car companies. And I'm discounting China a little bit because there's a lot of stuff that happens in China that you could call being successful. But this is, I'm thinking North America, Europe. Tesla has achieved something that really nobody else has in terms of hitting the marks. But let's not kid ourselves. For all the value they have now, it has been a rough road. They've had massive quality issues. They've had a lot of issues around the cost of their vehicles and their ability to make a profit. So I think the lesson is, it's almost like Tesla's proving the exception, right? Proving the rule that it's hard to make cars and it's hard to be a new company coming in and doing that. So what Apple's actually doing is not trying to make the car themselves. They're going to partner with companies that actually do make the car from a literal assembly perspective into final design stuff. So they're going to be, I think, smart about this. I don't know that it's going to disrupt, but I will tell you that traditional automakers are very carefully watching what these non-traditional players do, how they want to participate, and what direction they're going to drive. The other lesson from Tesla is Tesla, for whatever success they've had, has forced the other traditional automakers to be better at what they do. And that level of competition from a company doing one thing and doing it really well has put pressure on GM. And you see reaction from GM. They've put pressure on the European, German automakers, and you start to see that reaction from Volkswagen. So I think it's healthy. I don't think they will all of a sudden dominate, but I think the competitive pressure is always a good thing.
Just looking at some questions, we're going to avoid, focusing on Clarios, but more talk about basic trends in the industry. So the next question is, with a focus on end-of-life solutions, how do you foresee government environmental regulations will respond to the evolving battery industry?
I think that's a really great question. And that's one of the things that we are actively paying attention to in terms of how regulators view the need for this. In the case of, I use the case of lead acid as sort of the, what I think can be done well. In the case of lead acid, the lead acid automotive battery is the most recycled consumer product in the world, particularly if you look at Europe and North America. Almost 99% or 99+% of the batteries that are in vehicles today, when they're done, they're going to go through a recycling process. And then something like 95 to 97% of those materials are going to be reused in other products. So it's a really good story. Now, that was not created by regulation. There is not a regulation that says those batteries must be recycled. It was created by economic incentive, right? There was an economic incentive for the industry to capture those and use those materials. And it goes back to what Jim talked about at the very beginning, which is it helps defray your costs. It helps you find a better, more sustainable cost if you know you're going to be able to take those products back from consumers, put them through a recycling process, reuse those materials, and it creates, as I said, an economic incentive that naturally propels itself. The question will be, can that happen with other technologies? And I think, or are we going to require some sort of nudge from regulators to sort of force it to happen, as an incentive? I think that the regulators are going to watch it very carefully around acknowledging the need to do it, that it has to be done, that the alternative of landfilling batteries is not going to be acceptable. And then understand, is the industry going to take the lead on that, or do they have to be nudged along a bit?
Yeah. And Craig, I just go back to my former experience at Johnson Controls. We did have people in Washington, D.C. that would communicate with the government and with regulators in terms of technology improvements that we were making as a business towards sustainability.
Right.
And we would sit down and, present the cost benefit analysis, always in the direction of trying to become more sustainable in a cleaner industry. And I think with that cooperation, we actually, in some cases, had pushed regulators to say that we can meet this standard, and if you impose it, we'll be there.
Yep.
And we can also say we couldn't meet this standard. This is what we're doing to get that done. So, you talk about a push pull. Productive conflict, where I'm saying there was also productive cooperation in terms of this is what we can do and this is our progress. So go ahead and make your rules. We'll follow.
Totally agree. And just to build on that, because I think it's a really important point, Jim, you're absolutely right. And a rule is not a bad thing, right? Because especially rules that we were able to help shape by saying, this is what we know can be done, and we can exceed what you're asking us to do, so let's raise the rule. Not only does that hold us accountable for our own performance, but it raises the bar for the rest of the industry, which ultimately makes it a better industry.
Okay, another question from Maria is, U.S. startups are doing great in pharma, not so great in batteries in terms of funding and exits. The profit margins are very different, much higher for pharma, and the profit is achieved in Far East Asia, not in the U.S. We know silicon, we know electronics for packs, we invent new materials. How can U.S. startups succeed in the lithium-ion battery space?
Okay, I'm not on mute. I can answer that because I just looked at I took a relook at Ralph Broad's report. I think if you go back and pull that report, Adele, you'll see that what Ralph Broad talked about in 2006 has actually come true, and that is the manufacturing development for lithium ion has matured in the Asian countries, and it's going to be very difficult for U.S. startups to get a foot in that, and as a result, shamefully, I must say that if you want to take any lithium ion developments that you have up to a higher development, you're going to probably have better luck in Asia getting it going than you will here in the U.S.
Yeah.
Craig,
Yeah.
you can comment on that.
Yeah, for sure. I think in the course of what's happened with lithium ion, I think that's absolutely true. I think that there's a couple other dynamics that make it difficult. In the U.S., we've seen in my career, we've seen what I don't want to be totally dramatic, but somewhat. We've seen really the death of corporate R&D, corporately funded R&D. The way public companies especially, are held accountable for performance here means that R&D becomes a sacrificial cost that is eliminated. So we rely almost, versus an LG Chem or a Panasonic or a CATL, who have pretty massive internal R&D resources and budgets, in addition to being able to go out and scout, startups and other sources. In the U.S., we are largely dependent on a startup culture funded by venture capital, which venture capital has it's useful and it's necessary, but it has a very specific desired outcome, which isn't really aligned always with actually seeing the product get to market and be useful in the market. What they want is they want to get it far enough that they can hand it off to someone else or go public and generate a massive amount of value for their company, their fund. There's and actually, Jim, if you don't mind, can you put that that slide from Ralph's presentation up because I think it's really important to illustrate this point. By the way, hi Maria, nice to see you. So on this chart around the different stages of development, you know, it's not said here, but there is a phrase that occurs somewhere between applied research and advanced development. It's called the Valley of Death. And a lot of technologies go to the Valley of Death and never make it out because, you know, the VCs are very interested in seed money. They're very interested when these relative cost indexes are 2 to 5. But when you go to an order of magnitude greater, because you require capital, you have to build pilot lines, you have to invest in materials manufacturing at a scale that's much more significant, the VCs are not going to bring that money. They're not going to capitalize a startup to get to that themselves. The expectation is there's some sort of corporate partner who's going to come along and do that. The challenge is in that development phase, there's still enough uncertainty and enough risk that it's a difficult challenge for a corporate to say, I'm going to fork over that amount of money on a speculative opportunity. So I'm not saying it's impossible, but I would say it's contributed to the sort of, Maria, I think as you said, you know, underperformance of these opportunities here in the US, because there's no lack of startups. Let's just be clear about that. There is no lack of startups around battery materials or battery technologies and everything sort of in that ecosystem. The problem is I think you have so much challenge getting from that applied research into the advanced development and commercialization process. It's just a very, very difficult road to walk and expensive.
I mean, is it difficult? I guess that was one of my questions we spoke about in the past. You know, when we're evaluating some of these very early stage technologies, how do we know who might be a winner? And I know you mentioned there are some signs, you know, like with Maria and her startup, where they were able to get those government funds and SBIR funds. And if you get those, it's a good sign that there's some interest. You know, what else might you say about that? And also, you know, venture investors, are they, there's a lot of startups, are they investing a lot in this area, or are they shy of it because of Asia?
We're seeing on that, just to answer that question real quick, and I'll go back to the other one. We are seeing an upswing, especially in the last 18 months of VC money going into battery technologies. There was a bit of a bubble that happened earlier in the last decade and didn't work out real well. And so I think there was some fear. They pulled back a bit, but I think it's starting to happen a bit more. And I'm not going to name names, but you do need to be careful because you see there's some things that are happening right now that are commanding a lot of headlines around battery companies at lab scale demonstration going public and generating huge valuations. That's a house of cards that may or may not stand. And I'm not going to judge that, but you know, that's one path. The other path I think is more constructive, which is, and this gets back to your question about SBIR and other stuff. The best success I've seen in the last 10 years around companies that actually make it from an idea to lab scale to initial pilots and start demonstrating that have gone through the program at ARPA-E. And ARPA-E, for those who don't know, is a subset of the Department of Energy. And their specific goal versus other Department of Energy programs, their specific goal is to look at moonshot technologies, right? Things that are highly risky and highly likely to fail, but if they are successful, have transformative potential. And so, for instance, a lot of the solid state work that's happening here in North America is top shelf, even on a world scale. So this is a case where I don't know that Asia is necessarily ahead on what comes next, right? They are with respect to large scale production of, you know, for automotive grade or other lithium ion today for sure. But I would say the ARPA-E program has done a good job of creating a number of potential winners in the solid state space. And it's, to me, that's an example that process and that system can work, but it does take the intervention of the government, frankly, to help fund some of that bridging that that maybe, you know, the old Bell Labs kind of model, the GE R&D stuff might have, that it might have done that, you know, 30, 40 years ago. I think the government needs to step in and really keep those programs active. The good news is I think in the current environment, they're going to stay active, and if nothing else, they'll actually increase. So that's good.
We have a question from Adele. He's trying to understand the direction of the industry with announcements regarding EVs becoming the major market. Does this demand further research on lithium-ion batteries, or are there other technologies better fit for this application?
Jim, you wanna take that one?
Let's see. Is this Adele's question here? I'm trying to understand direction of the industry.
Yep.
Everything.
Yep.
Yeah, with it. That's a tough one. You know, and I look at this and I say, you know, I think everything is going to happen on an evolutionary process, not necessarily a revolutionary process. So, you know, I think, you know, beyond lithium ion batteries, what is there? Probably better lithium ion batteries for now. Let's see what else. So will EVs become a major market for batteries? Absolutely. The
Yeah.
question is, you know, how will EVs evolve into our current vehicle fleet? And I think it's, you know, will eventually go from hybrids to plug-in hybrids to EVs, and who knows? In the future, we may all own an EV, and we may all own a hybrid for long distance driving.
Right.
And I think that's just going to come along ever so slowly.
Yeah, I would echo that. And you know, I think I think the verdict is in that we are going to go to EVs, but that the path is not, it's not a seismic event. It's more of a slow transition. You know, for all the announcements and for all the hype that EVs get, you know, in a typical year, if we hadn't had COVID, we would have made globally about 90 million vehicles, and less than 2 million of those vehicles would have been EVs. So 2 million is a lot, but in the grand scheme of things, total production, it's still a relatively very small part of it. You know, the expectation that might go to 10% or 12% by 2030, which is, you know, 10 years out, that would be considered fairly aggressive, because the changeover time, the amount of capital required to start transitioning these, as Jim said, how do you integrate these into the fleet? Not to mention the infrastructure requirements to do that, the effect that has on the grid, the fact that really for these to have good efficacy from a CO2 mitigation perspective, the power you're using to charge them had really better come from renewable sources rather than coal-fired plants, right? This isn't just about the car. It's about the way the car is used, how it changes the way consumers think about the car, and the whole ecosystem that goes into supporting that vehicle, because it's very different than an internal combustion engine vehicle. So there's a lot that has to happen to make that a reality. It's not as easy as flipping a switch at a GM plant and all of a sudden, you know, you're kicking out EVs. But I would also I'll just second on what Jim said on the battery. There is an avenue for research. I would tell you that the technology that's going to be used for the next 5 to 10 years is probably set with incremental improvements. The breakthroughs are they're going to be a ways out, and they're going to have to be pretty dramatic in terms of what you can do, because going back to what I said earlier, you're going to be displacing something that will have billions and billions of dollars of capital deployed to make lithium-ion batteries, roll-coated electrodes, the way that it's being done now. If you want to displace that, it'll have to be really, really good and come in at a pretty low cost.
Yeah. And Craig, it's really kind of funny in retrospect. I think about, the battery industry in general. And, I think the United States' last major success in terms of getting through the valley of death and getting into full commercialization was in the primary alkaline market. And, you would think about, well, why was that successful? And I think it's because the end game was more visible in terms of form factors, A size, double A size, triple A size, C size, D size. Those were all end targets that you could design for and fulfill a function in many applications and in many markets. And then we go into the 1970s, and if you remember the Polaroid cameras that had the film packs with their own little energy sources in there, and a lot of money was put into that manufacturing process. Why? Because there was a lot of high margins in those film packs and cameras. And people then put the money into the battery plant because it was not being recovered from the sale of the battery within the company, but it was being recovered from the sale of the film pack and the camera to the end user.
And Jim, if you contrast that with EVs today, this will change, but EVs today, if you pass the cost on to consumers, it doesn't make sense for consumers. If it doesn't make money for the automakers, it doesn't make money for the battery makers, it barely makes money for the materials providers. So what you just described as a motive to drive innovation, create the technology, create the product, get it to market, was driven by everybody being able to get something they want, including
at the end of the day. Yeah, exactly.
And right now, this is a case, somebody asked earlier about regulation. Regulations are forcing EVs. Relatively few people are asking for them in a real sense. I mean, a lot of people will say they want one, but when it comes down to it, are you willing to spend $5,000 more for the equivalent car? A lot of people take a step back. And that's not to criticize or judge, but it just points out that we're pushing a technology onto the consumer public that in many ways doesn't have that natural demand, doesn't have that natural motive that Jim described. So I think it's a really good thing to consider. What is going to drive innovation? What's going to drive adoption technology? If you can check all the boxes on creating that natural demand, then you have a chance for success.
All right, we only have 1 minute left, but we have 2 questions. I don't know if you're hopping on another call, Craig and Jim, or if you can stick around, or you can email answers to these questions. Up to you, but we don't have much time.
I'm checking. I've got about 5 minutes I can go over.
Okay, there's just 2 more questions that we want to briefly answer. Is there a significant improvement in the failure mode of lithium batteries, making this technology more acceptable in EV?
I would say one thing about that is that lithium batteries, even the best lithium batteries today, are still vulnerable, sort of at a base level, to the things that we think about when the Samsung phones and other cases where you've seen fires and whatnot. But what we have seen is advancements in how those batteries are managed and controlled within the vehicle that keeps them relatively safe. I think the risk of still having fires in these cars is there in certain conditions, but I think the automakers and the battery makers have done a good job trying to get that to an acceptable, I think the word acceptable is important there in terms of what we're seeing today.
Okay, and lastly, what role do you think materials constraints will play in the direction of battery technology, with China holding sway over a lot of the supplies of rare earth metals?
All right, I might be breaking up, so apologize if that's the case. So I think it's a really good point. There is the question of where materials are going to come from and what materials are going to get used. I think it's sort of, as we've talked about, it's locked in for lithium today. Of course, getting rid of cobalt and getting out of the the Congo is a priority. Is I look at technologies that are being talked about for long-term future, things that are at the seed stage now, a lot of emphasis is put on using materials that are widely available, obviously relatively inexpensive, but things that can be sourced within region. So if you're going to make batteries in North America for North American applications, let's find materials that we can get in North America so we don't have that reliance on China or any other specific region to provide a certain one thing. Now, I think that's an objective and it's a good goal. I don't know that it's going to be challenging to make that happen, but that should be part of the objective, to not be reliant on things that come from one place or two places, for sure.
Yeah,
Thanks.
that's a tall order, Craig, though.
It is. It is. Very tall.
Well, I don't want to keep you guys over time, but this was so informative. We really appreciate it. And everyone has, been dropping great questions and comments. We'll save those questions for the future as well. And thank you guys and all the attendees. Thank you so much. And we hope you'll join us again for another chat.
Yeah, thanks for all the questions.
I promise the next time I'll have my Christmas background off. I just realized it.
It was
All right.
festive.
Thanks,
Yeah.
everyone. Have a good afternoon.
All right, take
Bye-bye.
care.
All right,
Bye.
bye.